Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve some questions on forces and equilibrium. And the first of all, we are going to solve a question of the same topic from question paper 9709/45 for the session May June 25. And we are going to solve question number 7. Let's see what question number 7 says. It says two particles A and B of masses 6.5 kg and m kg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is 5 over 12. A is on the rough slope and B hangs below the pulley. The coefficient of friction between the slope and A is zero point 0.4. Given that the system is in equilibrium, find the set of possible values of M. Well, before we start the solution, we should know the fact about a particle when it is held equilibrium on an inclined plane. Look at this. About B, the slope is rough, and the particle A is held in equilibrium. So whenever a particle is held equilibrium, there are two possible cases. Okay, remember, if we don't understand the fact about a particle which is held equilibrium by another external force, actually what should be the natural scenario? Suppose here the particle is over here. So what are the possible cases? The particle was about to naturally, if it is just released, then it will slide down the plane. So this is one of the cases. But if you apply external force, then it could move up the plane. So there are two possible cases for a particle held equilibrium on an inclined plane. So let us write this scenario. Actually, we should know the fact, and before we start the solution, we are going to write this. There are two possible cases. There are two possible cases. Two possible cases for a particle held. A particle held in equilibrium on an inclined plane. Okay, what are the cases? Let me write it once again. So whenever a system is given to us, when a particle is held in equilibrium, we should not forget these two concepts. Look at this, I have written here, so please keep this in mind before starting the solution. There are two possible cases for a particle held in equilibrium on an inclined plane. Either the particle is about to slide down or the particle is about to slide up. So keeping these two concepts in mind, we are going to solve our question. So this is our question. Before we start solving this, let us collect all the supporting information. Okay, first of all, we will complete the diagram for A, because B is not to be considered here. First case, we will have to solve A. Okay, so for A, Let me complete the diagram. This is normal reaction and it is weight and our angle is alpha. Well, and then there is another information given that tan alpha is 5 over 12. Okay, so for tan alpha we should know that this is the diagram. Okay, and we know that tan alpha is equal to what? Sine over opposite over adjacent. So opposite is 5 and adjacent is 12. So what will be our hypotenuse? If it is so, hypotenuse is going to be 13. How is it possible? Let me show you. Look, 5 square plus 12 square is equal to 13 square according to the Pythagoras theorem. Okay, so our hypotenuse is going to be 13, and this is for A. We have completed the diagram. On completion of the diagram, first step of our solution will be finding the normal reaction, because the particle A is kept on a rough slope. Look at this, it is written over here, the slope is rough, so definitely there is a resistance to motion, frictional force. So let us find the frictional force, normal reaction. Normal reaction is R plus, there is no upward forces acting on particle A, so upward force is 0 and downward force is mg cos alpha. Okay, or R is going to be mass of particle A is 6.5, so 6.5 into 10, 6.5 into 10, 6.5 into 10, and now we will find cos alpha. Okay, so sine alpha is equal to sine alpha. Let me write this above that. Sine alpha is okay. Sine alpha is equal to, very sure it is 5 over 13. 5 over 13. 5 over 13 is sine alpha. That means vertical side or opposite over hypotenuse. Then cos alpha. Cos alpha is equal to, just opposite to that, cos alpha is going to be your adjacent over hypotenuse. So adjacent is 12. 12 over hypotenuse is 13. So our cos alpha is 12 over 13. Just here we will write 12 over 13. 12 over 13. Hence our normal reaction is what? R is equal to 6.5 into 10. 6.5 times 10 is 65, and if 13 divides 65, it is 5. 5 12 plus 60. So our normal reaction is 60 Newton. 60 Newton is our normal reaction. Well, we have got all of the supporting information. Now it's time to start writing our solution. We have not forgotten that there are two possible cases. One after the other we will solve the question. So between the two cases, first of all, let's assume the particle is about to slide down, that is supposed to slide down. So let's start writing for A. Look, we have not yet discussed anything about B. All of the discussion is centered to A. For particle A, if it is supposed to move downward, then what are the forces? We will have to resolve the forces, and our topic is forces and equilibrium. Well, let's see the concept. Whenever we find the resultant force, always apply the concept of the motion law of Newton. And what is the motion law of Newton? Driving force minus resistance to motion is equal to mass into acceleration. Okay, so if it is supposed to slide down, what is the driving force? Actually, there is nothing which is causing it move downward except weight. So weight is mg sine alpha, mg sine alpha. And what is the tension, what is the resistance to motion? Number one resistance to motion is tension, because there is another particle and hold which has been held tight between this with an inextensible string. That's why the tension is the major resistance to motion. And another resistance to motion is actually frictional force. And we know that the frictional force means mu into r, frictional coefficient into normal reaction, equal to mass into acceleration. Look at this, as the system is in equilibrium, so there should be no movement or acceleration at all. That's why right side is 0. Let us substitute the values of m and g. M stands for 6.5. The mass of the particle is 6.5. So let us write 6.5, 6.5 into acceleration due to gravity is 10. And sine alpha, we have already obtained the value of sine alpha is 5 over 13. So 5 over 13 minus mu. Mu is the frictional coefficient, which is frictional coefficient is given as zero point 0.4. So it is 0.4. And normal reaction has been obtained as 60. We have already obtained. Before starting the solution, always we will find the normal reaction first of all, before, because in case of a rough slope, equal to t. Okay, hence our t is going to be, let us write t. If we make t as subject, t is going to be, look at this, 6.5 times 1065. If we divide by 13, it is 5. 5 5s are 24. So this is 5 5s are 25. So let us write 25 minus 4 6s are 24. It is going to be 24. Hence our tension is going to be 1 Newton. 1 Newton for one of the cases. We should not forget that there are two possible cases. Tension is 1 Newton when the particle was supposed to move down. So the other possibility is when the particle moves up. So for moving up, the direction is, it is moving like this. Okay, and the concept we are going to apply is exactly same. Driving force minus resistance to motion is equal to mass into acceleration. Okay, if the particle is moved up, then what is the force actually here? Look at this, if the particle tries to move up, what is the force? Nothing but the tension. Only tension is trying to move the particle upward. So we will write tension as driving force, tension. And what are the resistance to motion? What are the resistance motion or resistance forces are? Number one is our weight. Weight is trying to move it downward. So that is mg sine alpha, and the other forces, as the plane is rough, so frictional forces also causing resistance, which is mu r, equal to, right side must be 0 because the system is in equilibrium. Now if we simplify these, if we substitute the values, our t may be on the left side. Okay, mg sine alpha, look at this, already we have found mg sine alpha is this. Mg sine alpha is going to be 25. Okay, and mu r, already we have found our mu r. Mu r is also 24. It is 24. So plus 24. just the direction has been changed, but quantity magnitude is same. So our tension is, for the second possibility, our tension is going to be how much? 25 plus 24, so 49. Hence our tension is going to be, hence our tension for the second possibility is 49 Newton. So long we were analyzing the forces acting on particle A. Now this is the turn of particle B. There are two possible cases for B as well. So we will write for B also. So one of the cases is either it will slide down, I mean move down or move up. So if the particle B move up, then what is the driving force for B? This, let us write the concept. Concept is driving force minus resistance to motion. Driving force minus resistance to motion is equal to mass into acceleration. Okay, so it is going to be, driving force is nothing but the tension is trying to move it up, and the resistance to motion, look at this, this is hanging, so the particle B is hanging, so there is no question of normal reaction or frictional force, anything else, just weight is trying to move it downward. So weight is the negative force here, or resistance to motion. So weight is mg. If you calculate, it is cos 0 degree, because angle is 0 in terms of this. Or if you use sine, let me write sine angle, it's all the same, sine 90 degree, sine 90 degree. Let us write sine 90 degree equal to, right side must be 0, because the system is in equilibrium. So let us see our tension. Already we have obtained our tension. For the first case, our tension was, let us see, first case tension was 1 when the particle was sliding, A was sliding down, B was moving up. In that case our tension was 1 Newton. So we are going to substitute 1 is equal to, mass of particle B is m, so acceleration due to gravity is 10, so this is 10 m. Okay, now if we simplify m, then m is going to be, hence m is going to be, if we divide 1 by 10, it is zero point 0.1. So this is one of the masses of particle, one of the possible masses of particle B. Then for another possibility, when the particle was sliding down, I mean if particle A moves up, then B will moves down. So for B, same concept, that is driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force, when the particle B moves down, driving force is nothing but weight. So weight is mg sine 90 degree. And what is the resistance to motion when the particle B was trying to move down? The tension is causing the resistance, and acceleration is 0, so right side is 0. Hence our T is going to be, T is equal to, mass of the particle was m and acceleration due to gravity is 10, so this is 10 m. Well, now if our tension, if we substitute the second value of tension, because this time particle A was moving up whereas B was moving down. Okay, so when particle A was moving up, the tension was what? We have already found that the tension was 49 Newton. It was 49. So let us substitute this. 10 m is equal to, 10 m is equal to 49 Newton. Okay, hence our m is going to be 4.9. Now if we look at the question has told find the system Given that the system is in equilibrium, find the possible values of m. That means m will have a range of values. What is the range of values? We can write finally, if we want to write the answer will be this. Look, the minimum value was what? Zero point 0.1. So it is 0.1 until point 4.9. This is our final answer. This is our final answer. That means when the mass of particle B is from ranging from zero point 0.1 kg to 4.9 kg, then the particle, both the particles will be in equilibrium state. So what does this the answer solution has been completed, but for your better understanding I would like to explain. Look at this. When m is less than zero point 0.1 kg, then B will move downward. Okay, sorry, B will move up. If the weight of particle, mass of particle B is more than 4.9 kg, then particle B will move down. I can include this sentence so that you can understand it well. Let me write over here. This is not the part of your solution, but for your better understanding I am just writing. Okay, so it will be actually, if the two values will be like this. If m is less than zero point 0.1 kg, 0.1 kg, then B will move up. B will move up. B will move up. First possibility, if mass of particle B is greater than 4.9 kg, 9 kg, then particle move B will move down. So this is actually the twist of the question. Actually, the answer can be written that the mass of particle B is ranging from zero point 0.1 until 4.9 kg for being equilibrium. But what does it actually mean? It means if the mass of particle B is less than zero point 0.1 kg, then it will move up. If the mass of particle B is more than 4.9 kg, then B will move down. Sorry, it is down. Here I should write down, not up. It is going to be down. It will move down when the mass is more than 4.9 kg. So this is all about this solution. If you can solve it and analyze the forces individually, then I don't find that this is very complicated. But initially the question seems to be very twisted, but factually this is not at all. So what is the first, once again I am going to the first concept. Look at this. The concept we have applied at the beginning is, there are two possible cases for a particle held in equilibrium on an inclined plane. Remember, you should not forget this. Either the particle is about to slide down or the particle is about to slide up. So in both cases you will have to resolve the forces. If you can do so, I believe that it will never be a difficult task for you. Well, let's see the next question, which belongs to the same concept, forces and equilibrium. The next question has been selected from paper 9709/42 for the session May June 25, and it is question number 3. Let's see what it says. A particle of mass m kg is attached to one end of a light inextensible string of length 2.6 meter. The other end of the string is attached to a fixed point on a horizontal ceiling and the string is taut. The particle is held in equilibrium by a force of magnitude 35 Newton acting in a vertical plane which is perpendicular to the ceiling and contains the string. The force acts in a direction perpendicular to the string. The tension in the string is T Newton and the vertical distance of P from the ceiling is 2.4 meter. Find in either order the value of M and the value of T. Okay, we know whenever we resolve the forces, first of all, we complete the diagram in term of triangle. So let us do so. If we complete the diagram, look at this. These are the directions. This is x-axis, okay, x-axis. And here, this is a triangle and another triangle is this one, okay. And which is the tension? This is actually our tension or the string. Well, now let us see what is the angle. Let it be alpha as well as this one is beta, okay. So this is the completion of diagram, and you know whenever we resolve the forces we should know the measure of the angle. So one after the other we can find the angles. Let us find the angle alpha on the left side. So for alpha it is, look at this, hypotenuse is given 2.6 and height is given 2.4, that means opposite. And we know that T, that means hypotenuse into sine angle, sine angle of sine alpha is equal to, you know, opponent is 2.4. Remember, without having the measure of angle we cannot resolve the forces. So our tension is given 2.6 meters. 2.6 sine alpha is equal to 2.4. 2.4, or our alpha is going to be sine inverse of 2.4 divided by 2.6. 2.4 divided by 2.6. Hence our alpha is going to be, if we use our calculator, using our calculator we got that our alpha is 67.38, 67.380101. I have taken some more digits after decimal, more than necessary, because actually to get the more accurate answer we can write some more digits after the decimal. Then if alpha is 67.38, so beta is going to be, look at this, total is 180. From 180 if we subtract this from 90 minus this, so from 90 if we subtract 67, look at this, the middle angle is a right angle. So from 90 if we subtract 67.3801, rest one is our beta. So 22 point, it is going to be 22.6198 6.5 degree is the measure of angle beta. So as we have got the measure of each of the angles, now easily we can resolve the forces, because you know for finding tension we always resolve the forces, and our topic is today forces and equilibrium. Well, then, first of all, we will resolve the forces horizontally, and you know the concept is the motion law of Newton, that is driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force for particle, this is for particle from the first triangle, not particle, first triangle, I mean left side, okay. For let us start with the left side, it is going to be, no, let us start with the right side. Sorry, it's a mistake. Driving force will be on the right side, a positive force. So it is 35 if we choose this triangle. So 35 cos beta, 35 cos beta is the positive force, minus the negative direction of x is what? T, T cos alpha for the second this diagram, this triangle. And as the system is in equilibrium, so there is no motion at all, right side is 0. Okay, have you forgotten that this is our topic is forces and equilibrium, so right side is 0. Now we are going to substitute the values, or 35 cos beta, we have already obtained. Beta is 22.6198 619,865 equal to tension into cos alpha. Cos alpha, the measure of alpha is 67.3801. Then if we make T as subject, so T is equal to, or T is equal to 35 cos 22.619865, which should be divided by cos of 67.3801. Hence our tension is going to be, tension in the string is going to be, using our calculator we get that tension is 83.99989. So if we round it up to three significant figures, it is going to be actually 84.00, 84.0 Newton. This is the one of the answers we should show. Okay, uh, actually exact magnitude will be 83.99, but we will have to round it up to three significant figures, then it is going to be 84.0. So this is the value of T. Now let us find the value of M, I mean mass of particle P. Okay, so for that we have resolved the forces horizontally. Let us resolve the forces vertically. If we resolve the forces vertically, our concept is actually same. Okay, the concept is motion law of Newton. So let us write here vertically, the concept is same. Driving force minus resistance to motion is equal to mass into acceleration. Now let's see what is the upward force, driving force. Upward force is, for P is what? For the first, I mean right side triangle, it is 35 and angle will be sine. Sine, first of all, if we take beta, we can take the right side first. Beta plus another one is also upward force. So tension sine alpha and minus the resistance to motion. So long these were upward force, now downward force is nothing but the weight, which is mg sine 90 degree, mg sine 90 degree, mg sine 90 degrees. Sometimes you may get confused that we simply write mg, why don't we use angle? That's why to remove that confusion, I just write that sine 90 degree, because angle will be 90 degree, equal to 0, equal to 0. Then let us substitute the values. If we substitute the values, we require m. Okay, so let us write m on one side. Acceleration due to gravity is 10 and sine 90 is 1, so it is going to be 10m. It is going to be 10m. 10m is equal to If they move their places, it is going to be 35, 35 sine beta, sine beta plus tension sine alpha, tension sine alpha. Or our m is the subject, so m is equal to denominator is 10 and numerator 35 sine beta, 35 sine beta, sine beta. Beta is equal to how much? 22.619. So 22.619. I do not have sufficient space, so I will have to zoom it out. Zooming is not necessary, just continue to write. Our tension was what? 84 Newton, or it was 83.99. 83.99. Then sine alpha, alpha is 67 point something. I require some space more. Let me continue writing again. Yes, that is the our step. So our mass of particle P is going to be, if we use our calculator, 35 sine 22.67 plus 83.99 sine 67.38 is equal to 9.099. That means if we round it up to three significant figures, it is going to be 9.0 9.1, sorry, 9.1, 9.10 up to three significant figures. So that is what the final answer to this question. And I think that this is not difficult at all for any one of you. And I tried my level best to explain every tiny part of this solution. Let's see one more solution of this session. The next question belongs to paper 9709/41 for the session May June 25, and it says three coplanar forces of magnitude P Newton, 5 Newton, and 10 Newton act at a point O as shown in the diagram. The resultant of the three forces has magnitude Q Newton and acts in a direction perpendicular to the force of magnitude P Newton. Find the value of P and the value of Q. So actually there is a twist in the question. Look at, directly they didn't mention the resultant force. They have written that the resultant force of magnitude Q Newton acts in the direction perpendicular to force of Pn. So P is this one. If P is perpendicular, I mean vertical one, so Q will be actually over here. And this is, look at this, they have written perpendicular to the force of Q. If this is P, if this is P, Q should be over here. So this is the actually twist of this question, because we may get confused that where Q can lie, or what is the direction of Q. So once again I am repeating that it is, as they have told, the Q will be perpendicular force to P. So this is actually our Q. Well, and we are going to solve question number 2 of this paper. First of all, we will have to complete the diagram, this angle and this angle. So let me draw the diagram. Well, before finding the final result, I have explained that Q is, direction of Q should be over here. But how can it be over here? How can we be so sure that it could have been, this is the condition is, it will be perpendicular to P, so it could have been on the negative direction of X also. Let's see actually finally where Q lies. First of all, we will resolve the forces vertically. If we resolve the forces vertically, it is going to be a driving force minus resistance to motion is equal to mass into acceleration. Okay, we are applying the concept of the motion law of Newton. So driving force for P, this is our vertical direction. Okay, so for vertical direction, first of all, if we take the right side triangle, it is going to be 5 sine 60, 5 sine 60 degree plus P is also acting upward. If you calculate the weight here, mg, P and sine 90 degree, P sine 90 degree, because sometimes if I simply write P, you may get confused. You may think that why are we not calculating angle in case of P. Actually, angle is calculated everywhere. Here angle is 90 degree. That's why sometimes it remains invisible. So P is sine 90 degree, and the negative one is negative force is third triangle. I mean the this triangle. So for this triangle, it is going to be our magnitude is 10. So 10 sine 30 degree. 10 sine 30 degree, sine 30 degree is equal to, as we have already seen that vertically, look at this, the resultant force is perpendicular to the force of magnitude. That means it is somewhat horizontal resultant force. So vertical resultant force is 0. Remember, we should understand that they told that the direction of the resultant force is perpendicular to P. That means vertically there is no resultant force, which is 0 actually. Okay, so our right side is going to be 0. It is 0. Now let's see sine 60. We know that sine 60 is equal to root over 3 over 2. So 5 square root over 3 over 2 plus P minus sine 30 is half. So 10 over 2 equal to 0. If we isolate P, then it is going to be, or P is equal to this is 10 divided by 2 is 5 minus 5 2.5 square root over 3. Hence our P will be, if we subtract 2.5 root over 3 from 5, the answer is going to be, it is 0.6698. So if we round it up to three significant figures, it is going to be 0.670. So this is the magnitude of P, 0.670. Now we are going to resolve the forces horizontally to untie the knot of this Q, whether Q is on the right direction or left direction. Okay, for that, this is now horizontal direction. So for horizontal direction, the concept is same. Driving force minus resistance to motion is equal to mass into acceleration. Okay, sorry, not mass into acceleration. Here, yes, it is mass into acceleration. Okay, now they have told that if Q is on the right side, if Q is positive, let's see what happens. Q is the first horizontal magnitude of force, then plus another one is also, look at this, P is our point. Okay, so from P P is the reference frame. So right side to P is positive for x-axis and left side to P is negative. So the first triangle, this triangle is also on the right side of P. That's why it is positive. So it is going to be 5 cos, how much is the angle? Angle is 60 degree, cos 60 degree. Then this is the next, it is the direction is opposite to positive. So that's why it is going to be negative 10 cos 30 degree. Cos 30 degree equal to mass into acceleration is going to be 0, because resultant force is, now if we add up q to the resultant force or subtract q from the resultant force, it is going to be 0. So right side is 0. We are going to untie the knot whether q is on the positive direction or not. Okay, so it is going to be, q is going to be 10 cos 30. 10 cos 30 means, actually cos 30 is square root over 3 over 2. So 10 square root over 3 over 2 minus 5 cos 60 is half. So 5 over 2. Now if we use our calculator, q is going to be 5 square root over 3 minus 2.5. 5 square root over 3 minus 2.5. So our resultant force is 6.16. It is 6.16 if we round it up to three significant figures. Okay, 6.16 Newton. Now look at this. The twist was whether q is on the positive side or negative side. If you assume it to the negative side, what would happen? It would be, look at this, it will be 5 cos 60 minus, no, it is 10 cos 30. 10 cos 30. In that case, if q is on the right side, look at this, let me show you, then right side is only, what is it going to be? On the positive side is 5 cos 60. 5 cos 60 equal to, look at this, if q is on the left side, equal to q plus 10 cos 30. 10 cos 30. Okay, now let's see what happens. 5 cos 60 is 5 over 2, and 10 cos 30 is 10 square root over 3 over 2 is equal to q. Now look at this. What is it happening? 2.5 minus 5 square root over 3 is equal to q. That means q is going to be now negative. Look at this. 2.5 is less than 5 square root over 3. So q is getting negative 6.16 Newton. That's why this is the point to be noted. Look at this. If we use q, if we assume q is on the negative side, then the force will not be equilibrium. Look at this. It is not the resultant force which will make it equilibrium. That's why it shows that q is on the right side, I mean positive x direction. Q will be the positive x direction. Simply you will think that 2.5 minus 5 square root over 3 is the resultant force of this one. Okay, 5 square root over 3 is the resultant force of this one. So as this is larger, so definitely q should be on the other side, negative side is larger, so you will have to add up force on the right direction of x, otherwise it will not be equilibrium or equal. I think you got my points. As the negative force is already larger, force on the negative direction of x is already larger, so if you want to make it equilibrium, then on the right side of x, I mean right direction of x, you will have to add up the force. That's why we have added this q on the right side, okay, as driving force. I think you got my point, and thank you all for staying with me, and may Allah bless all of the human beings with beneficial knowledge. Allah Hafiz. Fi amanillah.